Hello, this is a recording on how we describe the distributions of nominal data. Recall earlier we discussed in some depth how to describe distributions of continuous variables, and in this section we're going to actually talk about how to do similar things but with nominal data. Remember, a nominal variable is simply a variable whose actual observations are discrete levels. Since example, color. So a nominal variable might be the color of M&Ms in a bag, candy M&Ms. So the levels would be whatever different colors are in the bag or what colors are possible. And what we typically would record is the frequency or counts for each of the levels. And that is basically the concept. And so whenever we deal with nominal data, we have a number of discrete categories or levels, and what we typically look at are the frequency or counts with which each level occurs. Okay. In fact, let's see if I can put this on slideshow. Okay. We're going to begin with what are called Pareto Charts. Pareto Charts are widely used in quality but also used in many other fields. And essentially it's a bar chart. Okay, so the x-axis or horizontal axis would have each of the levels of the nominal variable. And then for each of those levels there would be a bar, and the height of the bar would either be the raw count or frequency, or sometimes we plot percentages. Okay. What's unique about the Pareto chart is it orders the categories by decreasing frequency. So if you were looking at some nominal variable, the Pareto chart would then give you an ordering of what are the most frequent categories to what are the least frequent. Okay, so Pareto charts are relatively easy to create. As I said, they're used in quality, they're used in healthcare. You might be interested, as an example, on types of infections in a hospital. So you have a frequency with which certain infections are occurring, and the Pareto chart would then order them from highest to smallest. And Pareto charts are often used to prioritize, say, quality or some sort of issues for the organization. Typically, it's a way of prioritizing what you might work on first. So if you're having, say, quality issues with a product, the Pareto chart might tell you what are the number one or two issues that you should typically focus on. So I'm going to use a simple example. This is a data set called returns, and this is information on product returned to a company over a 3-month period. So looking at the screenshot of the jump data table, you can see customer ID. That's not of particular interest here. You'll see the generic product types, how many were returned, in dollars, what was the cost to the company of the returns, and what was the reason for them to return. So we're going to take a look at this data using Pareto charts, and later we'll look at it with other types of charts. Okay, so I'm going to go ahead and let me first open up Jump, make sure I have the right version open. So I'm opening Jump 12. And I'm going to open the data set returns. I got to drop my Dropbox. And we look for returns. There it is. Should be there. There we go, returns. Okay, so I'm going to go ahead and work directly with the data. So among the things we could do, as I said, are bar charts. I'm not going to spend much time on them. I think Pareto charts are often, particularly for things like quality and continuous improvement, Pareto charts are more useful. But if you wanted to do a simple bar chart, you could go either to the graph menu, okay, and you could select the chart menu from the menu, or even Graph Builder. So I'll just show you quickly in Graph Builder. Say I wanted to look at the distribution of product. I could just draw product over, okay, and then I could draw over things like number returned. And then we could do a bar chart. So notice this is a bar chart, but it doesn't really break out when you look at it, the ordering with which most defects occur. Very quickly, I could have also done this with the chart menu. Chart primarily focuses on all types of bar charts, so I'm just going to quickly show you. So I'm interested in product, and by the way, I could actually be interested in two: product and reason code, and I want to look at number returned. So I just want to look at the data for number that are returned. Okay. So notice it's giving us a chart. We have each product, and then we have the reason codes associated with it. Under the report menu, there are many things that you can do here. You can create bar charts. I was looking for the, okay. Let's see what I want to do. Bar chart, line chart, needle charts, level options, and Y options. There are different ways we can change these. We can connect points, overlay markers, needle charts, and so forth. So this is another way you could actually try to represent the points. Again, it all depends upon what you're trying to actually do. You can show percents of whatever it's worth. But I just wanted to, my main point was just to show you that those other platforms exist to make bar charts for nominal data. But our focus is on Pareto, so we go to Analyze, okay, Quality and Process, Pareto Plot. So we go to Analyze, Quality and Process, Pareto, and we'll begin by stating our nominal variable. Jump calls that Y or cause. Cause because in the quality setting these are often causes of quality problems, so we'll put product, and then where it says weight, I'm going to put number returned. Okay. So here is our Pareto plot. This is a standard type of plot. You see each of our categories, and we're getting a count axis. If I click on any bar, it gives me the raw count. You can also, if you go to your report menu, change to a percent scale, which can have its advantages in comparing Pareto charts. And other options is a legend. I actually recommend this N legend so that you always have an idea of how many observations are behind this Pareto plot. So here we can see almost 12,000 observations. So that gives me some confidence in my interpretation. Again, there are many options that you can use. You can, for causes, you can combine them, color them. I'm going to label them. So for each one of them, you can see the percent contribution. So about 40.6% of returns are product I, about 30% product C. Now you also notice this line going across the plot, and it goes from the left-hand side to 100% on the right. This gives you cumulative percentages, and if you can also label those points if you want to. So what you'll find, let me spread this out a little bit. You find out that product I and product C combined contribute about 71% of the returns. If you add in product G, about 80%. So some people, for instance, in prioritizing work, would pick I, C, and G to focus on it because that's 80% of your returns. Okay. You also see we have a few out here that have very small counts. Sometimes when we have categories with small counts, what we do is, get this to work right, is to combine them into, I can hit it here. Actually, they're hard to do. What I'm going to do, there's something in here called category legend. And why category legend can be nice, I'm going to, by the way, this legend is also a table. Get it to focus for me. Okay, product. So you could actually deselect some of these. I was having a hard time getting them. Okay. So I'm just going to leave them all displayed. And my mouse is giving me a hard time, which in this computer it sometimes does. Okay. And D, basically categories 9, 8, and 7 are very small. And what you can do is, I've highlighted them. I could combine them into something. I can either call them other or simply not display them. So here I've combined 3 of them together. Notice combined they're only about 3%, so we may not even want to be bothered to looking at them individually. Also, the bar chart, Pareto chart, like a bar chart, is interactive. So if I wanted to subset the data and only look at product I could highlight it, double click on it, on the bar for I, and I would have a separate data table. So there are 149 records, okay, for product I. Now there's something about Pareto plots where one has to be careful, and that is how to interpret them. Now here we're showing percent of returns, but as you recall, there was actually another variable, which was cost. Well, the total number of returns might not be your primary interest. Maybe you're much more interested in what it's costing you, and in fact quite often that is the case. So let's create another Pareto plot. So I'll go to Analyze, Quality and Process, Pareto Plot. I'm going to hit Recall, but instead of weighting by number returned, I'm going to weight by cost, By the way, cost includes the number that are returned. Okay. And if we now look at our Pareto plot, we see there has been some change. And again, I'm going to create a percent scale, and I'm going to compare this Pareto plot with the previous one. Get it to show up. So I'm highlighting those two selection boxes in the lower right hand corner. Click on Arrange and put them side by side. So you can see when I weight by cost, product C is actually resulting in more cost, and product I is actually number 2. Okay, and G stays in the same position. So if you were focused on cost, one might actually be more interested than in looking at product C rather than product I. Okay, so I'm going to close these, and I'm going to open up another Pareto plot. And I have looked at, so far, I've looked at product, but what about reason code? Why are they being returned? Okay, so I look at reason code, and again, I'm going to weight by cost because I think that's more realistic to an actual application. Okay. So notice that if I look at this, I'm going to again do a percent scale. So roughly about 29% of the cost of returns is due to missing parts. So you can see missing parts, then damage, then wrong product. Again, I can label the cumulative percent points. So you can see about 53% of the cost is due to missing parts or damaged. But notice there's something missing here. I really haven't looked at the combination of cost for cost of returns. I haven't looked at the combination of reason codes and products. So is there possibly a relationship? For instance, the reason codes might be different for different products. So how do I compare these two nominal variables, reason code and product? Well, I'm going to go back and regenerate a Pareto plot. So I go to Analyze, Quality and Process, Pareto. Okay. So I'm going to hit Recall. But notice there's something called X grouping. So I can actually group the plots by some other nominal variable, and I'm going to use product. And again, I will weight by cost. So I create the plot, okay, and see if I can get these all on one page. And I'm going to switch to percent scale so we can compare them. Okay. So for product A, the primary reason for returns is missing parts. Okay. Then damaged parts, then wrong product. Okay. Well, notice not satisfied or late shipment or other does not occur. Okay. So if you look across the Pareto plots, you can see there are some considerable differences in the various reason codes. Okay. As an example, if we take a look at, let's say, product D looks similar to A. Okay. But if we take a look at product G over to the right, the big one is late shipments. So what we'd really like to do is examine in some way the relationship between product and reason code. So one of the ways are to do these grouped Pareto plots. Okay. So I'm going to actually open a different data set. Again, this is nominal data. So I'm going to open up a data set. And this one is called Pareto Defect. Okay. Similar idea. So this is open up this has to do again with a quality problem. So we have 5 products, a series of descriptions for defects that have occurred with these problems, and then we have a count of the defective items. So in this example, unfortunately, we have no cost data. So I'm going to try a different way other than a Pareto plot of comparing product and description, and what I'm going to use is fit y by x. Fit y by x is when you want to compare 2 columns, so I want to compare product and description. So I could again use Pareto plot, and I could use description as y, the causes, and I could use product as a grouping variable. But instead, I'm going to go ahead to fit y by x. So I'm going to make product the x factor, description the response. You can reverse those, by the way. It's not has to be exactly that way. And defective items as the weight variable. Okay. So we get what's called a mosaic plot, and we'll do more with these later on. See if I can expand this out a little bit. Okay. Mosaic plots take a little practice, but once you get used to them, they're very, very nice in terms of interpretation. So the x-axis are the products, and then for each product, the total number of defective items is broken out by causes. And to the right, this separate bar are the overall percentages. Okay. In the table down below, by the way, it will give you the percentages. In this table, usually all you want to look at are this thing keeps switching for some reason. Okay. Okay. So what I want to do is just look at count and row percents. Okay. And let's see. There we go. Okay. So what we're looking at, and this is having its problems. Not sure why. There we go. Let's see if we can get this to do it exactly what I want. Sometimes with the integrity recorder, some reason my mouse does basically whatever it wants to. Not sure why. Okay. Okay. So basically, if you look at the row percents in the table below, it gives you a percentage breakdown by product for each of the defects. So notice, for instance, product B actually does not have an O-ring. Okay. 0. So it has a very different breakdown. And if you right click in this mosaic plot under cell labeling, you can do things like show percentages, or you could show the labels for what each defect is. So you can see in general, O-rings are actually represent a fairly large percentage of defects, but they don't occur for product B. Okay, so if you were looking at product B, you wouldn't necessarily even consider O-rings. Maybe B doesn't even have an O-ring in it. Okay. Notice O-ring also doesn't, pore seal does not show up in B, so maybe B also has no seals, and scratches don't show up. So if you were looking at product B, you'd be looking at dents and figuring out why are dents occurring. Okay, so mosaic plots in general are a nice way to display the relationship between two nominal variables, and they're very visual, but they generally take people a little practice at first. And by the way, this detached bar to the right, if you right click in it, you can also get it to show you percents. These are cumulative percents over all of the categories of defects. So again, 41% are O-ring, and the next highest 25% is outside diameter damage, and so forth. So a nice way to explore relationships of two nominal variables is the mosaic plot. And for contrast, I'll just basically show you the Pareto plot. So you go to Analyze, Quality and Process, Pareto. So you could use the Pareto plot. So I'm going to make description, the cause, product, the grouping, and I'm going to weight by defective items. So this is the alternative, one of the alternatives to the mosaic plot. So again, you can see product A apparently does not have an issue with connectors, OD, scratches, or defective screws. B has no O-ring. C has no seal or dent problems or screw problems, and so forth. So you can see in talking about types of defects, one has to be very specific to the actual product. Okay, and I'm going to go back to the original notes, and there's more information in the notes. I'm actually not going to go through it, but if you go through the notes, you'll see it more or less goes through the issues I've just talked about. I did want to point out this is a no pie chart zone. Pie charts are just a wonderful way to hide information. Maybe if you've got 2, at most 3 categories, they can be useful, but there are lots of studies of visualization of data, and pie charts consistently come out on the bottom. Unfortunately, thanks mostly to Excel, people like to do 3-dimensional exploding pie charts. They're actually a worthless way to display data, and we will not use them. Okay. The last of this describes mosaic plots, and at that point, okay, we'll end the recording.